everybody. I'm back, Kevin Omar Lopez Castellanos, and we're going to be talking about AppArmor and HTTPS. So let's get into talking about the two protocols, then hardening suggestions. What you need to know about AppArmor is that it's exclusive to Linux, and it includes many incredible qualities like max security. And in this case, it's the mandatory access controls where it allows developers to restrict anything done in their distribution, their copy of the distribution, and would enable certain processes that they wish not to occur to be restricted while their system is being used. It also enhances security because it restricts software that could potentially be exploited, and it can remove undesirable elements from the security. And they're restricted under the structure of profiles, and they contain two modes. Enforce is where it actually enforces the actions, the rulings, and prevents applications from performing those actions that are defined as restricted. Whereas complain mode is more of a testing procedure where it allows one to test their rules before they switch it to enforce mode. Now it works on profiles where they're stored in the directory that you see above you, and they're all defined as plain text files, and they contain comments which can ensure that every single command that's put into the file has an instruction behind it so people can understand what exactly they're doing with these profiles. Next we go to HTTPS, and it's known as the secure version of the Hypertext Transfer Protocol. What happens is that this protocol is responsible for sending data between a web browser and a website, but HTTPS ensures that the data is secure, and it does that by using encryption, best known as the transport layer security encryption, or as more popularly known but now formally known as secure socket layer. It uses a technique known as asymmetric encryption, where it involves two keys: the public key that is shared between the two parties, and then the private key which only one certain person may have. So if it's a conversation between a web browser and a website, there are two keys involved, one key for the web browser and one key for the website, and encryption can only occur when both keys are involved. And once they're enabled, the traffic is encrypted. So even if it's intercepted, which is the primary concern with HTTP, if someone intercepts the packets because they're encrypted, if they don't have the keys to decrypt the encryption, they're just going to be seeing a bunch of jumble. They're going to be seeing a bunch of... I'm just trying to illustrate what I'm saying. It's a bunch of garble. So without those keys, what you can intercept is practically useless. AppArmor, we would first install any additional profiles that are already made, and we do that by enabling the universe repository, which can give us access to more tools. And as before, I include the Linux commands in order to do so. Then you use the package manager to install AppArmor profiles, which can allow us access to these tools. Now, these are the commands that you need to learn when handling these situations: how to enforce, how to switch a profile to enforce mode, and how to switch one to complain. And in the brackets, you have to learn what's the pathway in the bin directory, because everything's going to be stored in the bin directory. So you have to define the directory pathway. There's no other way around it. Next, you generate and add on to profiles. What that means is that you have to generate profiles which can allow you to monitor and create these profiles, and it allows you to learn what makes an app tick. You can learn the implications and the functions surrounding this app so you can figure out what exactly you wish to restrict, if you do wish to restrict this application. And I include the command below as before. And if you already have existing profiles, you can scan and audit it to determine any potential deviations, any errors from the enforcement using the logprof command. Next, we use the unconfined command. What this does is displays all the lists and services with open ports, meaning everything that could potentially be exploited. This can allow us to plan and determine which apps do we want to enable the protection of AppArmor on. You know, it's a common fact. Before you take any action, you have to investigate. You have to gain knowledge. You have to monitor. You have to know exactly what it is that you're protecting. What is it that you wish to protect? If you don't understand the environment that you're working in, then you're going to have a tough time managing this task. And that means you have to understand the status of AppArmor. What that does is that you can use the sudo command and the AppArmor status command to determine that command and determine whether or not AppArmor is running in your system. But I don't believe that's going to be necessary because with the version of Ubuntu we're using, it's already installed by default. It should be. But also with the status, you learn every install profile in this AppArmor. And it displays all the processes that are confined but that are running in the background. And that's the thing about AppArmor. This is probably our first time learning about it because it's exclusively running in the background. It does its best work behind the scenes, and that's how security should be. Now, these profiles are important because it enforces the good app behavior without having to rely on listing attack signatures, because every day an attack is modified. Every day a type of method can be mutated or modified or changed or innovated upon, to where even if we have the signatures of the previous versions, the new versions just might be clever enough to bypass them. So with this, we can ensure restrictions without having to rely on attack signatures to be our signals. Now, we're going to be using HTTPS to harden both the Windows server and the Ubuntu server. Now, HTTPS is a little bit more difficult because we have to rely heavily on the GUI and there's no necessarily clever command line trick around it. So first we have to configure the TLS setting for that website, and I include the instructions below because it's a very lengthy process and I don't have enough time to take everybody through it. That's why I also implore that you use the works cited slide at the end of this presentation because it contains these instructions. Next, you're going to be using the server that were provided, the IIS, to enable downloads of the HTTPS protocol. And again, very lengthy instructions, very technical, and I don't have enough time to tell you all. So that's why I included that link. Now, there are going to be issues. I'm pretty sure we're not going to be able to get it down on our first try. That's why when I went to the blogs, I was able to discover this method that could resolve practically the big issues in preventing us from being able to enable HTTPS onto our servers. And again, I include the links in my works cited slides, so you're more than welcome to check those. Now with Ubuntu, it has some more clarified instructions, and it breaks down into 3 major steps. But before we do anything, we have to log in to the server via SSH. I included the command line, the command to do it, and instructions on where something is supposed to go. Next, you have to enable that mod SSL, and I include the Linux commands below, and you're going to require a restart because once you configure them, you're going to have to restart them to ensure that when you monitor them, they're secured. Then you're going to have to create a self-signed SSL certificate because this gives us the identification that we're permitted to configure this system using this program. And it's a very big command, so this is what we have to do. The end is my works cited page. Again, I only got to take you down a little bit through this process, and I'm not the best with technical knowledge. That's why you have to heavily rely on your sources. Solid. That's the end of my presentation. Hope you have a good night. Peace, everybody.